What's up, guys? It's Mr. Bringle, and today we're going to be tackling the Match That Graph concept builder from physicsclassroom.com. Now, to talk about this concept builder, I'm actually only going to go over a few questions from the wizard level, because the questions throughout this are some of them will be repeated, like the questions that you do in the apprentice level will show up again, maybe on the master and on the wizard level. And it's just testing you multiple times on it. This is really, really great practice for translating a position versus time graph into a velocity versus time graph, or vice versa. So what I'll do is I'll just do 4 to 6 questions on the wizard level and talk about the process of how to get to the right answer. And that should be enough for you, hopefully, to catch on to that process and then apply it to the remaining questions. So let's get going here on the wizard level. So this right here, I am going to make sure I have a different color than red, since there's a lot of red on this website, and then we will go ahead and go from here. I am having some technical difficulties though. So, okay, now on this, what we're going to do is it gives us this graph here. So this is the given graph, and then we are going to click through our options over here to choose a graph that matches it. And of course, we are going to pick a velocity graph to match this position graph. So the first thing that I am noticing here is that the slope of this line is constant on the position versus time graph. And remember, the slope of a position versus time graph tells us the speed or velocity of the object, how fast it's moving. So steeper slope, faster; more flat slope, slower. This slope doesn't change. It's at an incline and it's always the same. So what that tells me is that my velocity must always be the same. Now, it is a constant slope. It is also a positive slope, which tells me that I am going to have a positive velocity. So since I have identified that, I know that the line on the velocity graph is going to be on the top half of the graph, the positive side of the graph. And on the bottom side, you have negative. So we will not have a line on the bottom. Now, if you start clicking through answers, you may find a couple things that sort of like, oh, this could be it or that could be it. I would advise you to go ahead and think of what the graph should look like, or even draw the graph on a piece of paper and then go find the answer that confirms your beliefs. If you start clicking through these, it is really easy to kind of get tripped up and accidentally pick the wrong graph. So that is just my opinion on that. Now, what we're going to do is I am looking for a constant and positive velocity, which means I'm looking for one that looks like roughly this. It should be a horizontal line on the top half of the graph, unchanging velocity. It's on the positive side. That's what we want to find. So let's go find it. Oh, there it is right there. So this looks like the graph that we want. We check our answer and we get a data way. Okay, we'll move on to the next one here. So with this one, a little bit different, because now we're seeing acceleration. So we can see that this graph starts with a very steep slope over here. And sorry, let me erase this as well so we don't get confused. Very steep slope, and then up here it turns into a flat slope. So remember, when we go from steep to flat, that means that we are going from fast to slow. So this shows us an object that is slowing down. And I'll just write that here. It's slowing down, and it is moving in the positive direction, okay? I'm going to write positive direction here. So positive direction and slowing down, and I know that because it starts down here at 0 meters and it finishes up here at some positive number for position. If it was starting at the top of the graph and moving backwards, then it would be in the negative direction. So for my velocity graph, the prediction that I'm going to make is, since it's moving in the positive direction, I know that it's going to be on the positive half of the graph. So it will not be in the bottom here. And if it's slowing down, that tells me that the velocity has to approach or end at 0 meters per second. So it should be starting at a non-zero value, and the object or the line should move towards 0 meters per second. So more or less, I am looking for one that looks like this, right? So now we will go ahead and click through our answers to find that option that I have predicted. It looks like this. This makes sense to me. Let's go back to our prediction here. That looks good. We start with a non-zero velocity and it ends at 0 meters per second. This object is slowing down and it's on the top half of the graph, which tells me that the velocity is always positive, even though it has a negative slope. That doesn't tell us direction. That only tells us the sign of the acceleration. So this is the correct answer, and we will go ahead and check our answer. And we get another data away. I'm going to do maybe 2 more here. So on this graph, and I'll need to erase this very quickly. On this graph, we are kind of doing the opposite. We're starting with a flat slope, and it is going to a steep slope up here, right? So this means we are going from slow to fast. Okay, so that means it is speeding up. Now, also direction, again, is going to be the positive direction of movement because the object starts down here near 0 meters, and then it ends up here at some non-zero position. Okay, so we know that that object is moving forward or in the positive direction. Now, since it's speeding up, I am going to see a change on my velocity graph, and I'm going to go ahead and make a prediction here. So it needs to be in the positive direction, so I have to have my line on the top half of the graph. There will be nothing on the bottom. And because it's speeding up, I know that it needs to start at or near 0, and it needs to move away from 0 like this. Okay, that would be my prediction. Starting at 0 meters per second here, moving to a non-zero value here. Let's go ahead and see if we can't find one that matches up with that. And you know what? It's the second one right here. Again, it's doing exactly what we were hoping it would. We have a 0 velocity to start. We have a non-zero velocity up here to end. This object is speeding up. It's on the top half of the graph. It's moving in the positive direction. We will go ahead and erase, and we will check our answer. Data way. All right, this will probably be the last one. Maybe I'll do one more. We'll see what the next one looks like. But in this one, we are given the velocity graph. We have to pick the position graph. So we're kind of going backwards now. On this velocity graph, we first want to identify the direction the object is moving. The direction it's moving is going to be completely related to which half of the graph the line is on. Excuse me. The line is on the top half of the graph, which is the positive half of the graph. This means that the object is moving in the positive direction. And then when I look at this line, I notice that this line does not have an angle to it. In fact, whatever this number is right here, let's just pretend it's 2 meters per second. That's the same value that this line is at the entire time. So that means that this one is moving at a constant velocity. Okay, constant velocity. So now what does that mean for our position versus time graph? Well, I have to have an object that starts near 0 meters or somewhere and it moves away from 0 meters. Doesn't have to start there, but in these graphs it typically will around that area. And it's going to move away from 0, so it should be going up the position graph. I don't always like to use up and down when talking about graphs, but it should start at the bottom of the y-axis and move towards the top of the y-axis. The second thing that we are looking for is the velocity being constant, which means that the slope of our line must also be constant. Slope of position time tells us velocity, and if the slope changes, then the velocity changes, and we don't want that. So we are looking for a graph that looks like this, which happens to be right in front of us. We can see it starts down here at 0 meters. It ends at a non-zero position, so it's moving in the positive direction. And we see that we have a constant slope here, and that is what we want. So we will go ahead and check our answer, and we get another data way. Okay, I will do one more since this is giving us another velocity graph. I think that is that's good. We'll do one more example that way. So again, going from velocity to position. Now, first thing we want to do is identify direction. Once again, this line is on the top half of the graph in the positive region. Every point on this line traces over to a positive value on that y-axis. So we do want to make sure that we understand that positive direction. And then the next thing is this object speeding up or slowing down? I see that it starts at 0 meters per second here, and then it moves to a non-zero value up here, which indicates that this object is speeding up. So now I need to go look for a position graph, a position versus time graph that starts near 0 meters. It's going to end at a positive value up here for position, and the slope needs to get steeper over time. So I need to start with a flat slope, end with a steep slope. This indicates that the speed or the velocity is increasing. So I would start with flat down here, and then I'm just going to go up like this and get a very steep slope, kind of nice curve there. And then that's what we are going to want to go look for, is second option right here. So that's nice. And we can go back and kind of match that up. Okay, yep, that looks good. We have the flat slope here. We have the steep slope up here. And it is moving in the positive direction. So we will go ahead and check our answer. We will get one last data way for this video, and that is going to conclude our discussion over the Match That Graph Concept Builder. I'm hoping that that is enough information on how to do these problems for you guys to be able to complete the rest of them. Thanks for sticking with me, and I hope you learned something.